Okay, so functions, I'm not going to go through the starters. So learning intentions, we are learning about function and how we can associate graph with them, explain the term function, and know that the input is the x coordinate and the output is the y coordinate. So you can see how it fits nicely with after straight line, because we're going to express a graph of a linear or quadratic function based on what we are going to give. So what are functions? Okay, so basically, if there is a quantity that relates to another quantity, we're going to try and make what we call a function between the two. So just think about if you got car parts coming in and you make a car on the other side, then the function that links both is what we call the assembly line, right? So that could be a way to represent a function. So another example, if you've got dirty clothes coming in, hopefully when they go through your washing machine, they'll come out clean. So what we call a function is f of x. So a function of x, that's how it's defined. You put in x as your input, and you get y as your output. And y is just f of x, a function of x. Okay? So that's what they call a function. An output y, which is a function of x. Think about a straight line. We had an output which was the weight, or sorry, the height based on the weight. A function of the weight would correlate to a certain height. A price based on how many miles, for example, we were going through. Okay, so different type of functions. Let's say I've got the first one on the left. They've told me that my function, okay, which is that rectangle function there with a wee, so a pentagon, yeah. So whenever I put 4, my function tabulates the 4 into 3 fours, or 3 times 4, then that would become 12, yeah? It's just a calculator, that function.
Yeah.
So the 5 will become 3 times 5, which is 15, and so on. The 6, if you were putting it into that function, would become an 18. So 3x give me that.
X or
Yeah.
whatever.
So another function could be every time you put something in, the function square that numbers. So if you're given the output, which is 36, what do you need to put in? That give us 36. Remember, so n will have to be squared. So what is the number square which give me 36?
6.
6. So that'd be your input. The next one is, what is the number that we need to square to give me 49? That'd be 7.
Yeah.
And the last one, 8. So we've used some of these when we were doing sorts. So you could write it like that as well as a function. So you've got 2 bubbles or 2 sets, the input sets and the output set. Or sometimes you see them written like this. You've got a function, the input, so you've got 0, 1, and 2. And my function here tells me that every numbers is times by 4, and then we take away 1. Okay, so 4 times 0 is 0. Minus 1 is just minus 1. 4 times 1 would be your 4. Minus 1. So 4 times 1, 3, yeah. And the last one, 4 times 2,
7.
8, which give us a 7, yeah. Okay, so now you've got an idea how a function would work. You may be given the output, you're going to be asked for what is the input, or you may be given the input, what is the output, or you may be given an input and an output and ask you what is the function that links them both, right? So a function can be thought of as the relationship between an input and an output, which is what we've been saying. So the standard way to represent a function is using a formula. Example, f of x equal x plus 4, f of x equals x, or the function of x is x plus 4. Yeah, so it's just the way they talk about it. So now, if you're asked to find f of 1, that means you substitute x with 1. So 1 plus 4,
5.
5. They might ask you 5 is the value of f at 1 or when x equal 1. Okay? F of a, so if you put a, you need to substitute x with a,
1
then
again.
your answer will just be a plus 4. Remember, we've just substituted x with a, then it's just going to be a plus 4. Okay? So as simple as that. Now, example, these are the type of example you may be given. So I'm going to let you try these. So you've been asked to calculate 3 values. The first one, h of 1. Then the next one, h of -3 and h of 5. So I'll give you 3 minutes and you can give me the answers. So this is a type of NAT5 type question you may be asked. It'll be 1 mark because they expect you, to be able to substitute a value in another one. So try them, all 3, and then we'll check the answers. Okay, are we good?
Mm-hmm.
Yeah. Okay, so what did we get for h of 1?
9.
9. Same, Kirsty, 9 as well, I take it.
Yeah.
Yeah. I think most of everyone would say 9. Yeah, basically what you've done, you've just replaced x with 1. 1 square is 1. 1 times 1, 10 minus. Okay. So that was easy enough. 9. What about the next one? -3.
Is it 1? 10 minus 9. -3 times -3 is 9.
Yeah.
10 minus 9.
So it should be 1.
Yep.
So 10 minus -3 squared. So this is the bit that is important to make sure that you put your brackets there. Because if you don't put the brackets, you're just going to do 3 square. But you are asked to do -3 square. So -3 times -3, which is 9. Then 10 take away 9 should be 1. Okay? So if you don't put the brackets, you might lose the mark. And the last one, 5 times 5 is 25. 10 minus 25?
Minus 15.
Minus 15.
Yeah, minus 15. Easy enough, yeah?
Yeah.
So now for the function x squared plus x, we've been asked to calculate g of 0, g of 3, and g of 2a. Remember, it could be f of x, or they can ask you to do g of x. It's just another way of naming a function. So again, g of 0 should be straightforward, yeah? You just replace x with 0. So 0 squared plus 0 is just 0.
Yep.
G of 3, 3 times 3, 9
9,
plus 3,
9, 12.
12. Yeah,
No story.
12. Now, G of 2a, so we remember what we need to do here is to put 2a in brackets. So we've got 2a square here plus 2a. Okay. So 2a square, remember you square the 2 and you score the a, you square both, so that's 4a square
Mm-hmm.
plus 2a. So we can leave it like that. So another question would have been give and then factorize your answer, for example. Then you need to find a common factor, so a being one of them and 2 being the other one. And then you would need to factorize, so that would be 2a times 2a plus 1.
Mm-hmm.
If you ask, but they've not asked us that, there's no point adding that in. Because if we add that in and we make a mistake, you've just lost yourself the mark that you had done there. Okay, so if we're not asked to do something, my best advice is don't do it. So we will be using a formula to represent a function. F of x, h of x, g of x. Okay, yeah. So this is another type of question we might be asked to do. So you've got a set of values, -1, 0, 1, 2, and 3. These are x. And then we've been asked to find the value of f of -1, then f of 0, f of 1. So you would build a table, basically. And then after that, they've asked us to plot them. So plotting means drawing your x-axis, your y-axis, and plotting every point, x and y, x and y. But we've just learned for the past couple of weeks the equation of a straight line, yeah? So that should be a straight line with a gradient of 3 going on the positive side and a y-intercept of 1. So if we've done our work properly, the points should be on that line with a gradient of 3. So let's have a look. So this is how you would plot this. You would answer the question. So they've asked us to put -1. So if you do 3 times -1, that's -3 plus 1 is -2. They've asked us, so you put the point, you go x equal -1, y equal -2. The next one is when x equals 0, so that's our y-intercept, c equal 1, yeah? So you put that point. Then the next one, +1, 3 times 1 plus is 4. This is national 4, by the way. I doubt it you'll be asked to plot all those points. But anyway.
Shame I plotted that in the exam.
Yeah, I think this is easy enough. They would ask you more or less to give like the gradient of the line, but it's just for you to remember that what we've been doing is used, for example, with a straight line function. So the last one is 3 and 10. And now at National 4, you've been asked to draw the line through them all. And you can see that the straight line there has got a gradient of 3. Yeah, as we go 3 up, we go along 1, so 3 divided by 1, and then the intercept is at 1. And that works fine. Okay, so that's one way of drawing a straight line. The next kind of curve or function that you may be asked to sketch is more likely to be that kind of functions. Okay, so let's have a look what it looks like this time. So we have a function f of x equal x squared minus 3, and we've been given 5 set of values. Okay. Find the value of f minus 3, f minus 1, etc. and plot them. So again, we're going to put our x and y axis. I'm going to start putting our points. -3 times -3 is 9. 9 minus 3 is 6. That's our first point, -3 and 6. Then the next point would be -1. 1 minus 3 becomes -2. So you can see the second point appearing at -1, -2 on y. The next one is when x equals 0. Then we've got a -3. And then let's see what happens when we go x equal 1. This time, we've got -2. So basically, we've got y equal -2 for 2 points, the -1 on x and the 1 on x. Okay, and the last point is 3 and 6. So now, if you're asked to draw this, you get what we call a quadratic function. Okay, so quadratic function is part of our topics that comes in relationship. So when we had a straight line, we were in that form of mx plus c. Whenever we're going to have x squared in our function, you will see a certain quadratic function appearing. Yeah, and that's what it looks like. So basically, you've got a new function now, which show a symmetry somewhere, and this one at x equals 0, we've got our axis of symmetry, because that point there is symmetrical to that point here, and the -1 is symmetrical to 1. And we have something else that we call a turning point. The turning point is where the line basically starts to turn back up. So, and it's a minimum turning point. And it happens when x equals 0. For this case, right? Okay. So now, let's look at this example. I've got f of x equal x minus 4. I've been asked to find an expression for f of 3a. So f of 3a, I would just say, okay, substitute x with 3a. So 3a minus 4 is my answer. Consider the function f of x equals 3x squared plus 2. Now find an expression for f of 2p. So that means you need to replace x with 2p. So you bring 2p where x is. So that means 2p squared,
4p squared.
which is 4p squared. So now 4 times 3 will become a 12p squared plus 2. Okay?
Mm-hmm.
Consider the next function, x squared plus 6. We've been asked to write down the value of f of k. Exactly the same process. But this time f of k is just k squared plus 6. So ideally, you would write the equal sign here. Now the next question is, if f of k equal 22, set up an equation and solve for k. So we need to solve k squared plus 6 equal 22. So this is how you do it. K squared plus 6 equal 22. I need to get rid of that 6. So how do we get rid of an add 6?
You subtract it on the other side.
Take away, yeah. Move it on the other side, becomes negative 6 if you want. Then that means k squared equal 16.
You can then bring the squared over, make it root 16, and then make it k equals 4.
Okay, so let's think about this. Remember when we were looking at a function with x squared? Did you remember every time we had a value on one side, we had a symmetrical value on the other side?
Yeah.
So that works for this. So you've given me the answer for one side of the parabola. But because of the symmetry, you need to give me the same value, but with its negative on the other side. So k squared equals 16 has got two solutions. The obvious one, the plus 4, but then the symmetrical part of 4, which is negative 4. Because negative 4 times negative 4 equals 16. Okay? And that's why at National 5 level, you need to give both answers to get the mark. So the thing I tell my student is, if you're asked to solve an equation, and in the equation you've got x squared, you need to get two answers. If it's just x, like a straight line, you get only one answer. When you do higher, we talk about x cubed, they are looking for 3 answers. And when you do advance higher, you get x to the power 4, then it becomes even more complicated because they use complex numbers to solve these equations. But you get 4 answers. Okay? So this is an important one to remember because it's so easily done that you will forget the second one. So what you do is every time you see need to set up an equation where I've got square numbers, I need 2 answers here to answer this question. And you can check it quickly because negative 4 times negative 4 is plus 16. And 4 times 4 is 16 as well. Okay?
Yeah.
So there you go. Remember 4 times 4 is 16. Negative 4 times negative 4 is 16.
I was trying to think of it all as a, well, in that kind of mindset of using a graph, that's...
Yeah. So if you remember the graph, we're going to draw some graph eventually when we do when we look at quadratic functions, we will draw a few graphs and eventually you will see what we mean by you need to have those 2 answers.
Yeah.
Okay.
Mm-hmm.
So for homework 12C,
1, 2.
5 and 7. Those are those are the ones with the stars in them. Page 105. So they shouldn't be too hard. They'll be very basic, basically based on functions. But again, type of question that you can get easy marks to pass, if you see what I mean. Okay, so let's have a look the type of question they would give you. So exactly what we've been doing so far. For the function f of x, find f of 4, f of 0, and f of minus 2. Work out the value of b if the point 1b is on the graph. Okay, so we're going to do this one so that at least you've got an idea. So the first one, I'm just going to do f of 4, right? Then you'll be able to do the rest. Let me grab the correct pen color. So first one, f of 4. equal 5 times 4 take away 2, yeah?
Yep.
Which is 18. I'll let you do f of 0 and f of -2. Now, if they ask us work out the value of b if the point 1b is on the graph y equal f of x. So this is x, remember, when you've got coordinate, and this is y. They've told us y equal f of x, so that means b equal 5 times 1 take away 2. So what's 5 times 1 take away 2?
Sorry, 3.
Yeah.
3.
So now we've got our b. So work out the value of b. That's it. That's how easy it is. Now find the value of x for which f of x equals 13. So now we've got the output of our function, and we need to find out what do we need to put in. So basically, it means solving this equation 5x minus 2 equals 13. What do we need to put inside this function as an x to get the output 13? So that's basically solving this equation. First of all, to get rid of the take away 2, we add 2. What's 13 add on 2?
15.
15. So that means 5x equals 15. And then the next thing is to get rid of the time 5, I need to divide by 5. That becomes 1, and that becomes 3. So x equals 3. Once again, do I stop here? No, I'm trying it. 5 times 3, 15. 15 take away 2, 13. So I know this is correct. So I'm coming out of this, and I've got 1, 2, 3, 4, 5 marks. Easy marks to get, and that's how they use sometimes functions. They're probably going to make it a bit harder by putting like a fraction, you know, just to see if you can use fractions. But you could do the second one using the exact same method that we've done for the first one. Okay? So I'll let you work out the second one. That was question 1, 2. Question 5 and 7. So again, for 5, we've got h of t is 100t minus 5t squared. Find h of 2, so you just replace t with 2, and h of -3, so t. Okay. Now find the value of t for which h of t equals 0. So that means you need to solve this 100t minus 5t squared equals 0. So that's what you need to solve.
To try and get.
So what you could do is try to factorize this, because you've got 100 and 5. So 5 is the common factor. You've got t and a t square, and t is a common factor. So that'd be the first thing you could do, is factorize, because when you factorize, you're going to have 2 factors. And that means to get a 0, either the first factor is 0 or the second factor is 0. So you're going to get 2 answers. And remember what I said, when you get a t square, you need to give 2 answers. Okay? So that's how you would do it. So factorize first, and that would give you your answer. question 7, we've got f of x, 5x plus 1, and g of x minus x plus 9. Find the value of x for which, so basically you're asked to solve 5x plus 1 equal negative x plus 9. That's what they've asked us to solve here. Which value of x would work for this? Again, you use your balancing method. I need to get rid of the negative x from that side to move it on that side. So if you move on that side, it becomes plus x, or you add plus x each side. So you end up with 6x, yeah?
Yeah, 6 is plus 1.
Plus 1, but I want to get rid of the 1. Take away 1, take away 1.
So
9 minus 1, 6x equal 8.
Yeah.
Yeah? I've skipped a step, but you know what I mean by you've got the 6x, you take away 1.
Yeah.
And then last step, divide by 6. Divide by 6. Yeah?
Yeah.
X equal
1.2.
8 over 6. Remember, you can leave it in as a fraction, but you need to simplify it to its simplest form at National 5 level. So they're both even. What can I do to each number?
Use 2 as the.
Yeah.
Whoops.
Okay. 4/3. So you can leave it like that. That's perfect. Or you can write it as 1/3. It's up to you. But I wouldn't go and do 4 divided by 3 and say
Yeah,
this
give it
is
as a decimal point.
1.3333 because you're going to have to make a choice here. You're going to have to decide where do you stop.
Yeah.
Yeah, so you leave it like that, it's perfect. That means you've not rounded, you're giving it to the exact value. Okay,
Yep.
so let's see what comes next. So graph of linear function. The graph gives a picture of a function. So we've got y and x, and here is f of x equals 0.5x, or a half of x basically. Yeah, so the gradient is 1 divided by 2. You can see it there, and it's a positive gradient, and the y-intercept is 0. So far, just a straight line. It shows the links between the numbers in the input, which is what they call the domain, and the output. That's what they usually call the range. So whenever you hear that term, domain is the values of x, and the output is the range. So think about the function, input x, output y. A function of the form mx plus c is a linear function. We've seen that. Its graph is a straight line with equation y equal mx plus c. Yeah? So far, nothing should be new to you now that you've done so many straight lines. C equals 0. We've noticed that. And that was it for the straight lines.
Wow. Is the functional notation part of that as well? Like, is that part of the
Yeah, so because we're going to move into doing quadratics, it's good to have an idea, what do they call a function? So maybe a question might come one day. We've got this domain, and if you can't remember what the domain meant, you might think, oh, this is something that I've not been taught, or I can't remember. Or the range for this function goes from minus 50 to plus 50, so you know that's the output. So it's just to give you a bit of you know, vocabulary that you may be faced with
All
one
right.
day. Okay. But you can see functions are quite simple. The type of question you will get is find f of, you know, -2, or what is the value of x if y equals 0, for example. Then you need to know that if it's a quadratic with x squared, you need to give 2 answers.
Yeah.
Yeah. So
Okay.
they're not difficult questions, put it that way.
Hopefully they're not. Fingers crossed.
Yeah.
No.
Fingers crossed. Doesn't ask me something trivial. That would be really horrible.